Welcome to another video on my Raspberry Pi 1 using running Raspberry and Linux and connected through serial cable via the Serial Pi Plus board, band cable and network cable. And this is the Raspberry Pi Cam, or RaspberryCam for short, which is turned on. And via band cable it is connected to this breadboard with quite some electronics and one to be added. So far I have been using Raspberry Pi for in kind of chronological order, reading analog devices, LDR, another LDR, and an analog to digital converter, using the serial peripheral interface. That more or less working. I started another project with I2C. So this is I2C chip which can control through outputs, 8 outputs, a number of LEDs and of course other devices as well. And I have connected a switch so I can run two algorithms that I adapted. Binary counter and up and down. Now a third possibility is, because I have several chips for the Raspberry Pi, this very small one. Well, yeah, it is quite small considering to this one and that one. This is the Max 522, and that turns out to be a digital to analog converter, where this is an analog to digital converter, but also it works on an interface I never used before. I didn't even know it existed. 3-wire SPI, and this one uses the original 4-wire SPI, which means negative cable select, clock, master input, slave output, master output, slave input. And yes, those are those 4 wires. While this uses slave select, it uses clock, but it combines the outputs and the inputs. And that means that where this one is actually both ways, and it is so bidirectional, this one is single directional. So this one is one way only, either one or the other, and I intend to go using it. So the question is, where do I use it? Well, the point is of course that here I am already using SPI, so I have the signals already. I just have to connect 3 wires and combine one. So, or combine 2 actually. So how will this go? Well, I have to find out how to save some space, because that is a problem right now. And this is a problem now, so I will disconnect this project for now and have some space here. So I'm not bothered with these wires. So that is the objective for now, and I do not expect to end it with this one episode, with this one video. So first things first, disconnect this one and then see how things in space end up, because this one will have to find a place. So let's see how that ends up. Right, the component has been placed, the max 522. 2 wires added but not yet connected. And to give an idea what it is here the pin out. So which pin of the chip is which channel, and let me zoom in. Now this one, careful, this one and this one are standard for SPI. This one is a replacement for combined MISO, master input slave output, and master output slave input. These are the outputs. Ground and voltage, well, those speak for themselves, basically. But how to do it? Well, that's another question. This is a remaining part of the SPI schematics. This is a max 535, which is a bit different from the 522 in that it has only one output, and mine has 2. So that means that this is not the same. So actually I should say, alright, CS bar is 1, going here, which is CS bar is this one. So I want to add some text and say, okay, hold on, where's my thing gone? Oh, you can see that I already added all these, but no, hold on, I have to add text being 1. Where is it going? Here. So this is my number 1. Clock is 2. Clock being 2. Then DIN being 8. Yeah, DIN being 8. Let's save before it goes wrong. Then we have, which one? Reference. Reference is 7. Do I have an FB? I don't have an FB. I have, oh wait, that's also nice. Voltage is 3. Voltage input. It's 3 in my case. And ground is 4 in my case. Then I have out. Well, that's the whole point. 5 and 6 are out. So I don't have an FB. I have out 1 and out 2. So let's just say this one is 5. And the other one is then 4. So this makes things a bit clear. So these two are going to be combined to 8. Clock is going to be sent to 2, and CS bar is going to send to 1. There's one caveat. I have to make some space because I have to put something here to be able to connect them. So that is one thing. Next is of course the actual making of it. So now that I have that in place and I know where to go, I'll have to wire it. So I think I'll finish this one first because I need to have a reference. Without reference, as has happened before, it's not working. Right, so this is for now the outline. I had to correct here a bit, so this is 5 output A, 6 output B, 7 not yet done. 1 is CS bar, 2 is clock, and 8 is digital input, which is the combined from here. The rest is all wired up, not only here but also here. So combined wires, and between the master input slave output and master output slave input I put once more combining wire, and for safety purposes I disconnected the MISO and MISO here, MOSI and MISO. I disconnected one of them here to not do any thing whatever can be done. Although the program is not running, but you never know, better safe than well, anything else. So here is now next to each other ground, no, power and ground, and the only thing is lacking now is output. That is because I don't have any output put in yet. That will be this LED, assuming that it's functioning, but that is for now wiring. Then from here, from the RaspberryPi, new IC, integrated circuit chip, some wires from here to here, from here, here and here, a combination of the two to input, and that is for now the situation. A lot of wires, and I hope I am not making any mistake. So where's the rest going? Well, oh, you see the oscilloscope having been set on SPI, clock, data, chip select, channel 3, and then here any half duplex, that was the term that I was looking for, bidirectional, bidirectional but one way at a time, which means in technical terms half duplex, where both directions at the same time is full duplex. That will be going here. So that has to be implemented yet. So where are we going from here? Well, taking output A for one, I am taking an LED, Yeah, I like this one. Going here for now. And assigning 1 has to be changed in direction because this is the ground connection. So let's put it here. A wire from here yeah, I was afraid that would happen. Let's try it in a different way. I don't like this. Oh, look at that. Hold on. There's a little bit of wire remaining here. Let's zoom in. Yeah. Okay, delete. Connect. Okay. And zoom out. Right. That's it. Then a wire to connect to ground. This one will do. So that step is next. From pin 5 to ground. Nice idea. Let's see if that works out. Alright, so I have now put an LED here and another wire to ground. In schematics, as I have shown you, from here to here, and well, right here you can barely see it, but a little bit hidden behind these wires is the LED connected. Does it do anything? Not yet, because that's the next step. How do I control it? And oh, by the way, this should be this one. Let's keep it correctly. Now this I'm not sure of either. Right now this is schematics. I wish I could erase this one, but okay. I intended to create my own drawing since this one is only 1 and not 2 as is this one, but for now it will have to do. So considering also this schematics, and you can see it has a 3-wire interface which is compatible to SPI, only half duplex as I said. Important is that it operates from a single 2.7 to 5.5 supply, which is very important because the Raspberry Pi can operate from 3.3 and 5. So that is nicely within this range. Very nicely. And this is the internals. which I do not really care about, to be honest. And then it comes down to programming. Now, there is one thing to say about, because if I open this program, and in the former episode I already showed it, this is the SPI. However, how different will it be when I use 3-wire? That I will have yet to find out. Am I using Python or C? That's another question. This is obviously in Python. So how I'm going to do it, that's a second thing. How I'm going to use this, well, I assume that it will work. So we will see about that one. Okay, then what's next? Well, after putting this together on the breadboard, putting this together in GSM, after locating this one and having to restart this, I come up with the question how to program. And unfortunately I find then some information that doesn't help me any further, except from telling that it doesn't work. Well, if it really does not work, then why deliver this chip with the chipset well, combination that I got with the board, with the Raspberry Pi. So then I find a post on SPI test, and 3-wire is SPI kind of. So I decided to once again use GitHub and copy it into this new file. So what I do is save this, exit this browser, also for now exit this one, and then I will have to compile. And this is my result from finding SPI, which isn't there yet, so let this be. So let's see whatever I come up with. SPI test, and important is setting the output to SPI_test. Now let's see what happens. Oh, that seems to go quite nice. Cross compile, that will not be necessary, I think. So let's just test this one. Oh, right. Can't open device, because I probably have to use sudo. On the, as well as for testing, no, I have to be here. For testing 3-wire, I have to use option -3. So sudo SPI-dev -3. Command not found. Okay. Then we do this. can't open device. Then it is executable. Okay. This is not what I expected, obviously. So let's go to the top. What device is it actually trying to open? Oh, that's a lot of code. So simply running it is, let's say, out of the question for now. That is too bad. Need to find something else. But this I will have to go back to. So no signal testing on oscilloscope yet. This is well, at least it's mounted on the board. Testing follows. And that is it for now. A lot of wires, some added. So now 3 projects, SPI, I2C and 3-wire SPI. Well, the latest test is not very promising, but well, who knows what it comes down to. Also wanted to show another use of a tablet with respect to this one. Well, it works, but a bit of clumsy still. And let's put the keyboard on, and therefore I have to put this one up. Alright, that goes. Then, yeah, and it shines through, unfortunately. Keyboard. Yeah, this works. Okay, so let's try SPI. Not that I expect it to work now, suddenly. Oh, right, because I forget the point slash. SPI dev test -3 for 3-wire. Can't open, aborted. Same here, but that was expected. Anyway, that's the way it goes sometimes. Unfortunately, it's not different. So, how to go on? Well, find a way to program it. They didn't give this chip for nothing. You can use it, so I will use it. And that's it. If you like this video, please subscribe to my channel. Give it a thumbs up. The video that is. Leave a comment or suggestion. You can also follow me on Twitter and Instagram. Please support my channel by making a small donation via PayPal or Wired. Much appreciated. You can also become a patron and have your name mentioned. Much more information, as well as videos and pictures, you can find on my website. Everything is listed under this video. So for now, thanks for watching. This is to be continued, and bye bye.